Hello, this video is on section 4.1, which is titled Congruent Figures, and the learning target for this one is to recognize congruent figures and their corresponding parts. So let's go ahead and get started. On this piece of paper I've drawn a few different shapes, and I'm going to be making a few transformations to them, and to just kind of show you some examples of how you can apply these transformations but still have congruent figures. So if this first one we have a rectangle, and let's say it's being shifted up to the left and to the right, none of the side lengths are changing and none of the angles are changing, so each of these two have congruent parts, the sides and the angles, even though it's being moved up and to the right. The same exact thing can happen to this one, where if it's being flipped or reflected to where it looks like this, each of the angles are still congruent and each of the side lengths are still congruent. So even though they don't look like they're the exact same thing, it's being flipped over, so each of the corresponding parts, all the sides and all the angles, are still congruent. And lastly, if you look at this triangle, it can be turned or rotated, and you can still look at the corresponding parts to where all of the angles are equal and all of the side lengths are equal as well. So looking at the corresponding parts, even though it's being shifted, flipped, or rotated, you can still have congruent figures. So more formally, you can look at some congruent polygons, which are any shapes. The congruent polygons are congruent if the corresponding parts are congruent, and the corresponding parts are the angles and the sides. So down below I've drawn a polygon that is ABCD and another one that is EFGH, and it's being flipped from one to the other. Now in the different colors I've labeled each of the angles A and E that are the congruent parts, B and F, C and G, and D and H. Now right here, when you write your congruent statement, or a congruent statement, you have to make sure that it is in the correct order based on what you're matching up on. So notice that A is first. Its A's congruent angle is with E, so E must be first right here. B goes second, so that means the matching congruent angle with B is F. That is what goes second. And same thing with C and G, then D and H. So when you write one figure is congruent to the other, you have to write them in order based on the parts. And down here I've also written a few other congruency statements that takes each segment and matching it with the other, AB to EF, BC to FG, and so on and so forth with the rest of the angles as well. Going into an example problem where you're trying to find a missing angle or a missing side length, and you're given that these two are congruent based on A, B, C is to D, E, F, so in order we know that A is congruent to D, E is congruent to B, which these two are both 30, so we know they're congruent, and C is congruent to F. If C is congruent to F and C is 75, then that means that F is also 75. Now using triangle angle sum theorem with EFD in order to get D, we know that all of them must total to equal 180, and 30 plus 75 is 105, and 180 minus 105 is 65. No, 75. So angle D is 75 degrees. Okay, and the last theorem that I want to go over is something that's called the third angle theorem. And that is if you have two triangles where you know that two pairs of them have congruent angles. So down here we have A, B, C, D, E, F. And if A is congruent to D and B is congruent to E, because of the triangle angle sum theorem, then angle C is congruent to angle F. Then the third angles are congruent. So the biggest thing in this video that I want to make sure that you guys understand is that even though the shapes may not look like they're congruent, if you look at specific parts within the shapes, like each angle or a side length even, to find their corresponding parts, those are congruent, then you will have congruent figures. If each congruent part is congruent, then the entire figure will be congruent. Okay, thank you.